In topic 3, we're going to now start factoring polynomials. So we're going to look at common factors of a polynomial. So there's a lot of new words here. The first new word is polynomial. You might remember this from grade 9. Polynomials are expressions that have coefficients, aka numbers in the front, like this 6 here and this 9 and this 6 down here and this 4, and they also have variables. So when you looked at polynomials in grade 9, you looked at like terms, you looked at adding and subtracting them. So now what we're going to do is we're going to factor them. Now, when we factor a polynomial, what we're essentially doing is we're splitting it into two new expressions that multiply to get the original polynomial. So let's look at example 1 here. Factor each binomial. Now, this word here, you might remember from grade 9 as well. Binomial just means a polynomial, but with two terms. Now remember, each term is separated by a plus or a minus sign. So you'll notice in example A and B here, there's only two terms in both of them. But both of these are still polynomials, okay? They're just a special type of polynomial called a binomial because there's two terms in them. So let's look how to factor these. So to start off, we want to look at the coefficients and the variables separately when we're factoring. So what I do here is I look and I start with the coefficients, 6 and 9, and I think to myself, what's the biggest number that divides into 6 and divides into 9? The biggest number I can think of is 3. 3 divides into 6 and 3 divides into 9, and there's no bigger number than that divides into both. So what I'm going to do is I'm going to put a 3 out here. Now this example is a little bit easier because there's a variable in this term, but there's no variable in the next term. So we cannot factor out a variable. So the 3 is the only thing we can factor out. So what we do is we write the 3 there, and now we're going to open a set of brackets next to it. And we need to think, 3 times what will give us 6n? Well, I know that 3 times 2 gives me 6, and we still need the n there as well. Now I'm going to put that plus sign, and I'm going to think 3 times what gives me 9? 3 times 3 gives me 9. And now we have factored this binomial. So we split this binomial into two expressions. So we have 3 is one expression and 2n plus 3 is another expression. And when we multiply them together, we get 6n plus 9. So we factored out the 3, and now the whole thing has been factored. Let's look at a little bit trickier of an example. So we have 6c plus 4c squared. This example here is a little bit tougher because now instead of just coefficients in both terms, we also have variables in both of them. So to make this a little bit easier for us, I'm going to write this out so we can see just how many c's there are in each term. So I'm going to keep the 6 here, 6, and there's only one c in that first term. So the first term just stays the same, but now I'm going to put the plus sign and I'm going to put the 4. Now, how would we write these c's expanded out? So how would we write them without using a power? Well, c squared, that's the same as c times c. Okay, so in the first term, in this one over here, we have 1c, and in this term over here, we have 2 c's. So now let's move on to actually factoring this thing. So let's start off with the coefficients once again, just like we did in A. Let's look at 6 and 4. What's the biggest number that divides into 6 and divides into 4? The only one I could think of is 2. So I'm going to write a 2 out here. Now when it comes to the variables, we want to think, how many variables are we able to pull out of each term? Well, in the first term, we have 1c. And in the second one, we have 2 c's. Now, when we factor out the c's, there needs to be that many c's available to us in each of the terms. So for this one here, I can only factor out 1c because in the first term, I have one of them available, and in the second one, I for sure have one of them available. we cannot factor out 2c's because in the first term there's only one available. So we can't factor two of them out of there. So 2c is what we can factor out of these two terms. And now let's write the rest of the expression so that when we multiply 2c to it, we will get the original expression over here. So let's look at the first term, 6c. And let's start off with the coefficients. 2 times what would give us 6? Well, 3. Now c times what would give us c? Well, c times nothing would give us c, or c times 1. So we don't have to write anything next to that 3 there. So now I'm going to put a plus sign over here, and let's look at the second term, 4c squared. So let's start off with the coefficients, the numbers. 2 times what would give us 4? Well, 2 times 2 would give us 4. Now c times what would give us c squared? Well, c times c would give us c squared. So there we have it. We factored out 2c from that binomial over there. So now if we were to multiply this back in, we will get the original expression here. So 2c times 3 would give us 6c, and 2c again times this other 2c over here would give us plus 4c squared. And that's what we started with here, so we know we factored it correctly. Let's look at example 2 here. Now we have a trinomial. So this is another one of those special polynomials that has a special name. So tri means 3. Just like a tricycle, there's 3 wheels. Now there are 3 terms. We have one here, and one here. So I'm just going to write down the original expression here. 5 minus 10z minus 5z squared. And let's put a little equal sign. So let's start off with the coefficients. So now we're looking at all 3 of these. We're looking at 5, 10, and 5. What is the biggest number that divides into 5, 10, and 5? Well, the biggest one I can think of is 5. So let's put a 5 out there. Now let's look at the variables, which is the z this time. We have to look at how many z's are available in each term. Well, in this one we have 2. In this one we have 1, but in this first term there's actually no z's available. So because of that, we actually can't factor out any z's. So 5 is the only thing we can factor out, so let's just write the rest of the expression here. So let's start off with 5 times what would give us this 5 over here? Well, 5 times 1 gives us 5. Okay, now let's look at the next term. 5 times what would give me negative 10z? Well, 5 times negative 2 would give me negative 10. And we didn't factor out a z, so that z just stays in there. And now 5 times what would give me negative 5z squared? Well, that would be negative 1. And the z squared just stays the same in there because we didn't factor out any z's. So this is our final answer here. We factored out the 5. That's the only thing we can factor out. Now the nice thing about factoring is that we can verify that the factors are correct. And we did that in the last one in red over here. We verified our answer is correct by multiplying what we have over here to see if it equals the original expression we had. So let's do that. We're going to check by what is called expanding. So we take 5 times 1 minus 2z minus 1z squared. And to expand that, we are going to multiply this 5 into every single term. So that looks like 5 times 1 minus 5 times 2z minus 5 times 1z squared. And if we keep solving this using BEDMAS, 5 times 1 is equal to 5. Then remember, coefficients multiply coefficients, so we would have minus 5 times 2, which would be minus 10, and that z is still there. And then minus 5 times 1 would give us minus 5z squared. So since this is the same as the original, so the factors are correct. So let's look at a little bit trickier of an example here. Factor the trinomial, verify that the factors are correct. So again, this is a trinomial. It's still a polynomial, but since it has 3 terms, we can call it a trinomial. So this one here is a little special compared to the other ones we looked at because all of the terms in it have a negative sign in front of them. So there's a little bit of a rule here. If all signs are negative, and that has to be every single one. So all the terms have to have a negative sign before it. Then you would factor out the negative. Factor out the negative. So let's work through this one by one. We'll start off with the coefficients. So remember, the coefficients are the numbers. Now, since all the terms are negatives, I am going to put a little negative sign here because we're going to factor that out. Now let's look at the actual numbers. We have 12, 20, and 16. So we need to think, what's the biggest number that divides into 12, 20, and 16? The biggest number that divides into all of those is 4. So -4 is the number we would be factoring out. Now let's look at each variable. Now this time we have 2 different variables. We have x's and we have y's. So let's start off by looking at the x's. So we have 3 x's in this first term, we have 1 x in the second term, and we have 2 x's in the third term. So the most amount of x's that we could factor out is 1. So I'm going to put 1x over here. And now let's look at the y's. We have 1 y in the first term, 2 y's in the second term, and 2 y's in the third term. So the most amount of y's we can factor out is 1. So I'm going to put 1y over here. And now we have to write an expression that can multiply to this to get our original expression. So let's start off. I'm just going to erase all these little notes I have here. Let's start off with the first term here, -12. So -4 times what gives us -12? Well, -4 times 3 would give me -12. Now, x times what would give me x to the power of 3? Well, x times x to the power of 2 would give me x to the power of 3. Remember, we need to add the exponents when we're multiplying variables here. And I'll just do a little side note. X times x to the power of 2. Well, there's an invisible exponent 1 here. These are the exponent rules you learned in grade 9. So you need to add the exponents. 1 plus 2, which is equal to x to the power of 3. So that's how we get that x times x to the power of 2 is equal to x to the power of 3. And then y times what would give us y? Well, nothing. We don't have to multiply y by anything to get y, so we just leave that as it is. And we move on to the next term. Now, -4 times what would give us -20? Well, -4 times +5 would give us -20. Now let's move on to the x's. X times what would give us x? Well, nothing. We don't have to multiply x by anything to get x, so we leave that as it is. And y times what would give us y squared? It would just be y. And then the final term here, -4 times what would give us -16? That would be +4. -4 times +4 gives us -16. X times what gives us x squared? Just an x. And y times what gives us y squared? Just a y. So there we have it. We have a fully factored trinomial. So we factored out -4xy. And this is what we have remaining here. And we can check by expanding, just like we did before. So we are going to distribute this first factor into the rest of the expression here. This is called the distributive property. You might remember learning that in grade 9. So we're going to distribute the -4xy to all the other terms inside the brackets. So then this would equal negative 4xy times 3x squared plus negative 4xy times 5y plus negative 4xy times 4xy. And if we multiply all this out, we have negative 4 times 3 gives us negative 12. X times x squared gives us x to the power 3, and then the y times nothing is just y. Okay, good. That matches our first term up there. Then let's look at the second one here. We have negative 4 times 5 gives us negative 20. X times, no x is over here, so we just have an x, and y times y gives us y squared. And finally, negative 4 times 4 gives us negative 16. X times x gives us x squared, and y times y gives us y to the power of 2 as well. So this is equal to the original expression we have up here. So that means our factoring is correct. In our final example here, we're taking it one step further, and that is we need to simplify by combining like terms and then factor. So now we have to remember how to simplify an expression. We need to remember what like terms are. Now, like terms need to have the same variable, same variables, and same exponent. So let's look at all of our terms here. Let's start off with this term here with the y. Are there any other terms that just have a y in it? Looking. Oh, this one over here has just a y. So that's the same variable, and the exponent on the y is 1, so that would be a like term. Let's look at our next one here, 7xy. Are there any other terms that have an xy in it? Oh, look. There's an xy, so those two are like terms. Okay, let's look at this term with an x to the power of 3. Are there any other terms with x to the power of 3? There sure are, right over here. Let's look at this one with just an x in it. Are there any other terms with just an x? There isn't. And same goes for the next one here. Are there any other terms with a y squared in it? Just a y squared? Nope, I don't see one. So those two terms in the middle there don't have any like terms. So now let's combine these like terms. So I'm going to put a little equal sign here. And let's start off with the y's. So we have a negative 4y over here, and we have plus 2y over there. Well, minus 4y plus 2y is minus 2y. Now let's move on to the xy's. We have positive 7xy over here, and we have negative 7xy over there. Well, plus 7 minus 7 gives us 0. We have 0xy, so we don't even have to write that one down. Let's look at the x cubes. We have negative 2 over here, and we have plus 10 over here. So negative 2x cubed plus 10x cubed gives us plus 8x cubed. And then we still have the plus 28x and the plus y squared to put in, these two right here. So now we simplified this expression. Now we have to factor it. While recording this, I just realized that there's no way we can actually factor this expression here. So I'm going to cheat a little here, and I'm going to change this example so that it actually can factor for us. So what I'm going to do is I'm going to add one more term to the end here, and we're going to do minus y squared. Now when we do this in class, I'll make sure to add that in at the very start. So what we're going to do here is we have plus y squared, and you know what? Let's cancel that one out with this minus y squared. So plus y squared, that's technically like plus 1y squared. And on the end here, this is like minus 1y squared. So these two are going to cancel each other out. We're left with 0y squared. So in this next step here, I'm just going to erase this y squared. Because now we'll actually be able to factor this thing a little bit. And I didn't realize that when I came up with the question, so I apologize. So now let's factor it. So let's look at the coefficients first. We got negative 2, 8, and 28. What's the biggest number that divides into all three of those numbers? Well, that would just be 2. So we're going to put a 2 here. And let's look at the variables now. Let's start with y's. Sure. Are there y's in each term? Oh, there isn't. So we can't even factor out any y's because there's only y's available in the first term. Let's look at the x's. We have 3 here, we have 1 here, and we have none here. So we can't factor out any x's either. So the 2 is the only thing we can factor out. So let's open up our brackets here and think. 2 times what gives us negative 2y? Well, that would be like negative 1y. Okay, now 2 times what gives us plus 8x cubed? That would be plus 4x cubed, because 2 times 4 gives us 8, and the x cubed stays in there. And 2 times what gives us 28? That would be 2 times 14. And don't forget about that x in there. Now I just want to point out that we don't even have to put this 1 here. We can just write this as 2 and then negative y plus 4x cubed plus 14x. And that 1 just stays invisible there. And we're done. That's how we simplify and factor this equation. And of course, we can check our answer by doing the distributive property. So if I rewrite this whole thing again, let's distribute that 2 to everything inside the brackets. So we would get 2 times negative y plus 2 times 4x cubed plus 2 times 14x. So 2 times negative, remember there's an invisible 1 here, so 2 times negative 1y would give us negative 2y, plus 2 times 4 is 8x cubed, plus 2 times 14 is 28x. And that brings us back to this original simplified version of the expression. So we know we got the right answer.